Hello everyone, I am Samir Khan and our today's topic is natural language processing for smart healthcare. This paper is published in 2022. So, what is natural language processing? Natural language processing is a subfield of artificial intelligence that focus on the interaction between computer and human language. It actually involves the development of algorithms and models that enable computer to understand, to interpret, and to generate human language that is meaningful and useful. So, why to use natural language processing in smart healthcare? Natural language processing can play an important role in smart healthcare. Natural language processing can be used to extract valuable information from unstructured clinical notes, medical records, and research papers. It can assist healthcare professionals in making accurate diagnosis and treatment recommendation by analyzing patient histories and medical records. NLP can analyze patients' data to predict disease at risk and identify at-risk patients. Also, it enhances patients' care. It also enables computer to understand and process human language effectively. In introduction, this paper is a comprehensive review of natural language processing for smart healthcare. It covers various NLP techniques and their application in smart healthcare scenarios. Techniques like rules-based, statistical-based, and deep learning-based models. This paper also discussed the role of NLP in addressing specific medical issues such as mental health care and COVID-19 pandemic. The author review existing studies that concern NLP for smart healthcare for the perspective of techniques and application. This paper provide insight into the current state of NLP and identifies future direction and research in this field. Also, it provides current limitation in NLP applications. So the main problem addressed in this paper is the application of NLP techniques. This paper provides a comprehensive review of various natural language processing approaches and their application in the clinical practice, hospital management, personal care, public health, and drug development. NLP in smart healthcare can improve patients' outcomes, reduce healthcare costs, and enhance the overall quality of care. Now, moving towards smart healthcare. So, in this figure A shows the major participants in smart healthcare, includes the public healthcare service providers and the third party healthcare participants. The figure B shows the example of emerging technologies which enable smart healthcare application, which include artificial intelligence, blockchain, cloud computing, and the IoT, Internet of Things. The figure C shows the representative smart healthcare scenario, which include intelligent research and development for life science, public health promotions, smart hospitals, and health monitoring, etc. This paper discusses the three categories of natural language processing approach. It actually compares the different NLP approaches, which include rule-based NLP and statistical-based and neural-based NLP. Rule-based NLP involves designing rules to extract information from text which can be quite accurate in specific cases, but it requires expertise in both computer science and linguistics to design appropriate rules. And it is easy to interpret and understand, but it has limited coverage due to the flexibility and complexity of human language. And also, it is not suitable for large scale applications. The rule-based NLP includes following steps. The um, first step is rule creation, then rule application, then rule processing, and then rule refinement. First, rules are crafted to specific how the systems should interpret and manipulate the text. Then during rule application, these guidelines are used to analyze and extract meaningful meanings from the text data. The ruling processing involves systematically applying these rules to the language patterns and structures. And as the system encounters new data, the rule refinement may be necessary to enhance the accuracy and adapt to evolving language. Now we discuss some of the rule-based NLP approach. One of it is pattern matching algorithm. It is a two-step process for gene mention identification in the text documents. In the first stage, it gives gene mentions using the synonym list, comparing the synonym to the words in the document for exact matches, which may sometimes result in the false positive and misses. The second stage generates a candidate gene by identifying the 1,000 closest document based on the word indicator, feature vectors, and combining gene list from the neighbor documents. And at the final stage, the gene mentions are refined using a Jero-Winkler similarity scores, which should be greater than 0.85, comparing them to informative synonyms and considering common characters and substrings, ultimately improving their accuracies. The second type of approach, which is discussed in this paper, is statistical NLP approach. It is superior to the rule-based NLP in performance, but it requires domain expertise to create handcrafted features and is limited to taking full advantages of available data. It has some advantages like it gives better performance than rule-based NLP in application with abundant data available, and it has some disadvantages like it has low interpretability and have dependence on expensive computing platforms, and it may not perform well with the limited data. Here are some examples of statistical NLP models. The first one is a bag of words. Bag of words is a statistical NPL model that represent a text as a bag that is multi-set of its words. In this model, each word is considered as a separate feature, and the frequency of each word is used to measure of its importance in the text. The bag of word model is easy to implement and has been widely used for various NLP tasks such as sentiment analysis, topic modeling, and text classification. However, this model neglects the importance and sequential order of words in sentence, which can limit its accuracy in some applications. The second model is TF-IDF, which stands for Term Frequency Inverse Document Frequency. It aims to improve the measurement of words' importance in the text. In this model, the term frequency of the word is the number of times it appears in the text, while the inverse document frequency IDF is a measure of how rare the words is across all texts. The TF-IDF scores a word in the product of its TF and IDF values, which gives a higher weight to the words than a frequent in a text but rare in the corpus. This model can help to identify important words and phrases in the text and has been widely used in various NLP tasks. However, it still does not take sequential order information into consideration, which can limit its accuracy in some applications. The third model is n-gram. N-gram is considered as a sequence of n words or characters as a single feature. In this model, each n-gram is treated as a separate feature, and the frequency of each n-gram is used as a measure of its importance in the text. N-gram models can capture some of the sequential order information in a text and have been widely used in various NLP tasks such as language modeling, speech recognition, and machine translation. However, the computational complexity of n-gram models increases exponentially with n, which can limit their scalability and efficiency in some applications. The third approach, which is discussed in this paper, is neural NLP approach. Neural NLP uses deep learning techniques to learn features automatically from the data, which has shows uh, a promising result in various NLP tasks that can handle complex and unstructured data and requires large amount of data and computational resource to train effectively. It has some advantages. This approach is more natural for processing text and speech input and is capable for remembering historical information. And it has some disadvantages it has training issues like short-term memories and lack to learn local features and position information. Also, it lacks in interpretability. And now we discuss some of the natural NLP based models on the next slide, like RNN based, CNN based models, GNN based models, and other different models. So the first one is the RNN based model. This model is designed to process sequential data such as text and speech. In this model, the input is fed into the recurrent neural network RNN cell, which has a hidden state that can capture the historical information of the input. The RNN cell is applied iteratively to the each element of the input sequence, and the output of each iteration is feedback to the next iteration as a part of input. This allows the RNN to maintain a memory of previous input and use it to predict the next output. However, RNN suffers from the problem of gradient vanishing and explosion, which can make it difficult to train them effectively. To address this issue, more advanced RNN-based models such as long short-term memory (LSTM) and GRU, that is a gated recurrent unit, has been developed. This models used specialized gates to control the flow of information in the RNN cell and prevent the gradient from vanishing or exploding. This LSTM and GRU model have been shown to be more effectively than the traditional RNN in processing long sequence and capturing longer term dependencies in the text and speeches data. However, they still have some limitations such as training issues and short-term memories. The next model is the CNN based model. This model are designed for learning local features from the text data. Input is processed through the convolution neural network, which is CNN. The CNN applies filters to the input sequence extraction like ngram or word embeddings. These filters scan over the input sequence, create a feature map that identifies a specific feature in different locations. Then the feature map then goes through a polling layer, which aggregates and reduces the output's dimensionality. This allows the CNN to focus on the most significant feature of the input, which is useful for tasks like text classification or sentiment analysis. This CNN based model excel in computational efficiency and handling large datasets, which are making them suitable for deep neural networks architectures. However, they may struggle with capturing long-term dependencies um, and text data, which can be the drawback of some NLP tasks. The third model is a GNN based model. The GNN-based model incorporates knowledge from the graph structure entities in the neural NLP. Input is represented as a graph with the nodes for entities and the edges which denotes the relationship. The graph is processed through a graph neural network, which is GNN. GNN applies graph convolution operations to the nodes and edges, extracting special features that captures structural and semantic information. Efficiency for it has efficiency for handling large or integrated graphs and can model diverse relationships like concurrence, similarities, and hierarchy. However, this model struggles with capturing long-term dependencies in sequential data like text and speeches, which is a limitation in certainly all and in all NLP tasks. And implementing and training this GNN model with a large and very complex graph can be challenging. The fourth model we have is the transform-based models. Transform-based models are specialized neural networks, neural NLP models for effective processing of long sequences with support of parallel training. Input undergoes a self-attention mechanism which enable each element to consider all others, calculating their weight, sum of their representation. This empowered the transformer to grasp global dependency in the input sequence and bypass the gradient issues seen in the RNN-based models. So this is highly effective for handling lengthy sequences, long sequences, applicable in NLP tasks like machine translation, text summarization, and question answering. However, this also may struggle to learn local features and position information, which can be a drawback in the specific NLP task. The fifth model is combinations model. It is basically the combination of two different models like CNN LSTM and RNN attention. So the combination will be CNN LSTM with attention model and many different models. The sixth one is non-conceptual embedding oriented pre-trained models, which offers distributed dense vectors as word embeddings. These embeddings remain static and don't adapt with changing context for a word. This means the same embedding is used for a word regardless of its context in the sentence or document. Ideal for tasks not needing detailed syntamic or segmentic informations like sentiment analysis or topic modelings. And however, they might not fully capture a word's meaning in diverse contexts, make them less suitable for tasks needing the understanding of language, such as question answering or machines translations. The last and seventh model is con contextual embedding or oriented pre-trained models. Uh, these models incorporate the dynamic contextual information into word embeddings. These embeddings grabs the word meaning in various contexts suitable for tasks needing detailed segmentic synthetic informations. Uh, like question answering, machines translation, and named entity recognition. Examples are including birth, GPT, ELMO utilize the transform architecture for uh, for exceptional performance in the combination of other words embedding methods. However, these models are usually large and costly to pre-trained and restricting the widespread use, particularly in the field like healthcare. Now we talk about the NPL pipeline for smart healthcare. It basically has three main components. First is pre-processing, then feature extraction, and the last one is modeling. Input to the pipeline can be either text or speech.
The pre-processing is the first step and involves tasks like tokenization, stop word removal to prepare the data for feature extraction and modeling. In feature extraction, which involve extracting relevant information from pre-processed text, method like bag of words, TPIDF, which we discussed earlier, and word embedding can be used for feature extraction. And models are developed for various NLP tasks like text classification, information extraction, and natural language understanding. Then extracted feature can be directly used by classifiers and regressors for simple tasks like medical text classification, and for complex tasks, additional steps may be needed to provide the features. The pipeline may also include speech-specific tasks like speech recognition and speech synthesis. The modeling has so many different procedures like text classification, text generation, knowledge engineering, speech recognition, speech synthetics, etc. Then it generates the output. Here are the some applications of natural language processing. This table shows the category of applications, subcategories, and representative application and their related techniques. So the first one is a clinical practice in which the patients provide their communication, then the clinical documentation is done, and the clinical decision support is been done. Then the next application is the hospital management, which has patient flow management, resource allocations, and quality controls. In the personal care, they actually monitors health, their behavior changes, lifestyle management, etc. And for the public health, they see the diseases, outbreak detections, and the health policy analysis. For the last application, that is drug development, they discover the drugs, adverse drugs event detections, and addressing specific medical issues like COVID-19 pandemic and mental health care. Basically, NLP has led to the significant advancement across the various aspects of smart healthcare to hold the potential to revolutionize the entire healthcare industries. This is the basic structure of NLP driven applications. First is the user. User means we, and the user interface where the user provide text or speech input, which act as an entry point to the user interaction. Then the third one is the backend, which receives and processes user input with the NLP models, delivers result and specific services back to the users through the UI. The backend component involves NLP models, which is responsible for understanding and processing user input. We utilize the various NLP techniques here, which is described earlier, and there are the supporting models and knowledge-based models, which are essential for knowledge-dependent applications like knowledge-based question answering. A system it stores and provide access to relevant information and data. Here are the two medical driven smart healthcare for the specific medical issues like COVID-19 pandemic and mental health care. During the COVID-19 pandemic, the preservation to analyze the social media data for the early outbreak detection we do. Then they did the diagnosis for extraction relevant information for clinical notes and electronic health records to aid the clinical decision making. Then after that, they developed the drug, identified the potential drug candidates for the COVID-19 treatment. And the second issue is the mental health care. In the early detection, they analyze social media data and online for forums to identify signs of depression and anxiety. Then they do diagnosis and the treatment, extracting patient information from the clinical notes and patient interviews to support diagnosis and treatment planning. And after that, they do supports and counselings. They develop chatbots and virtual assistants for the mental health care counseling and supports. The NLP techniques have some limitation like understanding human languages, their interpretability, and the implementation is very hard. It also gives us the future direction for combining multiple NLP techniques and for developing the end-to-end applications for the few short terms learning. In the conclusion, NLP can transform healthcare by enhancing accuracy and efficiency in diagnosis, treating, and preventing medical issues. It is also important for interpretability in NLP driven applications, especially in the clinical setting where low quality assurance is crucial. And the despite of deep learning, statistical NLP remains relevant in numerous healthcare studies and applications. This paper offers the exploration of NLP techniques and their potential roles in the smart healthcare. According to me, this is a decent paper which describe different NLP approaches in a smart healthcare for making decisions and predicting the diseases. It also discusses the various applications of NLP approaches and some medical issues. However, they didn't propose their own method in this research, but they compare the previous known methods. Uh, Thank you. If you have any questions, do comment below.